So at the bottom of my page here, that's the work that I did for the questions from Mastery Quiz 5.5A, which was some nice practice on the optimization we've been studying. If you're watching this, it's probably worth your time to pause and look at the ones you're looking at. But since some of you are here listening, I'm going to go through it anyway. So you can see, hopefully, I've clearly delineated the workspace for 1, 2, 3, and 4. I guess I could do this here. That might help between 3 and 4. And number 1, I decided to present 2 ways of doing it since it's multiple choice. It doesn't matter what calculus you're doing. You're looking at the slope of the line through 0, 0, and the point on the curve at 1, 2, 3, and 4. So as the question is, which of these are a minimum, I know that whichever one is the smallest is going to be the minimum of the minimums, right? So that was why I decided to cheat and just calculate the points 1, 6. So I substituted 1 into the curve, 2, 3, and 4 into the curve. And that's where I got my outputs. And then the slope is 6 minus 0 over 1 minus 0 because it's through the origin. This is the smallest of those. If you want an equation, the equation would be the slope equation, which is the change in y. So it's the change from the y value of the function, which is x squared minus 4x plus 9 to 0, and the change between the x values of the point going into the function x and the x value of the origin, which is 0. I divide it by x and then take the derivative, and I get plus and minus 3. I know negative 3 isn't it because it wasn't one of the options presented. Number 2 was the one that actually took me the longest because I made a small mistake in it that made my work not come out right. More on that later. But we're looking at a version of one of the classic problems we did in class on, well, earlier this week, whichever day that was. And this one is not an open-topped box, it's a closed-top box, but we can use the same kinds of ideas. So we have a square, forgive my not accurate representation. I just said that using the volume formula you're given, length, width, and height, length is going to be the longer measurement, width is going to be the shorter measurement, and height is going to be x. So looking at this measurement here, there's the 2 little corners we're cutting out again, which are both x. So the total distance is 40. That means that this distance of this flap right here is 40 minus 2x. Which is going to come up again when we look at the other side, which again is longer in drawing, but is still 40. So it's 40, but there's these 2 additional pieces. Now I know these additional pieces are the same. I know they're the same because the box's bottom here and top here have to be the same. So I used that to say that this distance is going to be these x's, and then these I just called y, and when I add all of those together, I get 40. So that's where I got the 20 minus x from. So the volume is 40 minus 2x times 20 minus x times x. I distributed, took the derivative, got 2 values where v prime equals 0 at 20/3 and 20. I discarded 20. Oops, that should say 20/3. I discarded 20 because if x is 20, this measurement right here is 0. So I know it can't be 20. So only 20/3 to consider. So I looked at 20/3 and I checked to see, I actually did it on the graph. The graph is positive and then negative. So that is a maximum, and that's why we choose letter D. For number 3, we have a continuous function on a closed interval. So notice the first thing I did was I evaluated f at 0 and 3 and got 7 and 6.1. I was in a hurry, so I didn't get the decimals accurate to 3 places. So don't sweat that. Again, it's multiple choice, but for completeness sake, I think it's worth mentioning. So I checked f of 0 and f of 3. And that meant the only thing that was left then was to determine the values between 0 and 3. And that's going to happen when f prime equals 0 or does not exist. Well, I know for this type of function, polynomial function, when I take the derivative pictured here, there's going to be no values where the derivative won't exist. So the values I got from solving this are 1 and 2. So I substituted 1 and 2 into, again, the original f, not f prime. I got 6.5 and 6.6. 7 was the maximum. The answer choice is C. Number 4 was a version of the question that we did in class with just different numbers. So I knew that one side is not going to be used twice. I called that y. I called the other side x. 2 of those. The perimeter is 18. So 2x plus y is 18. The area is x times y. So I solved this for y, which is 18 minus 2x. Distribute x, take the derivative. I got 9 halves, and then if x is 9, y is 9. If x is 9 halves, multiply that by 2, subtract it from both sides. Y is 9, multiply those together, you get 81 halves, whatever the units are, square feet.